so today we learned how to take all the factoring we've been talking about and be able to solve a quadratic function. So you're basically setting all of the roots or all of the solutions that you get when you factor it equal to 0. So I'll show you with number 1 what I mean by taking them and setting them all equal to 0, and then after that you can see kind of the pattern. If I take x minus 9 and set it equal to 0, x is going to be positive 9. If I take x minus 3 and set it equal to 0, x is going to be positive 3. And if I take x plus 2 and set it equal to 0, x is going to be negative 2. So you can see the pattern that it's just the opposite of what's inside when you have no coefficient in front of the x. So it's just x and not like a 2x or a 3x or something like that. So these would be my 3 solutions. And we're talking about a polynomial function. So it looks like an S-shaped graph if it's a cubed root, and or if it's a cube, and so it would cross 3 different places, and those 3 places would be where it would cross the x-axis. Okay, so all these solutions are roots or zeros or x-intercepts of the graph. All right, so in some of these you'll have to factor. So x plus 7 is already ready to get a solution, which is negative 7. But this can still be factored, and that gets factored into, let's see, x minus 3 times x minus 6, okay? So you actually have x plus 7 times x minus 3 times x minus 6. And the reason I knew that that was factorable is because there are 2 numbers that multiply to give you 18 and add up to negative 9. It's negative 3 and negative 6. So my x solution here would be 3, and my x solution here would be 6. So I would have 3 solutions, and those 3 would be it. All right, number 3, you would need to factor out an x because they have the x in common. That would leave you with x squared minus 4x minus 45. Okay, so if there's this x that's out here still has to be set equal to 0, just like the x plus 7 got equal to 0 in number 2. So the x by itself is going to be equal to 0. That means that is one solution. Then you need to factor these 2 numbers that multiply to give you negative 45 and add up to negative 4 would be x minus 9 and x plus 5. So I would have another solution at 9 and another solution at negative 5. So my 3 solutions are 0, 9, and negative 5. And again, whatever is in front of that parentheses has to be set equal to 0 as well. All right, for the next one, they have a 3 and an x in common. So I would be left with x squared minus 5x plus 6. Okay, so again, whatever's in front of the parentheses has to be set equal to 0, and we need to solve. So x will be equal to 0. That's one solution. And then I need to factor this. I'm looking for 2 numbers that multiply to give me positive 6 and add up to negative 5. That would be x minus 3 and x minus 2. So I would have 2 more solutions at positive 3 and positive 2. Okay. Number 5. 4 terms tells us that we're probably going to group. So we'll take these 2 and take out what they have in common. They have a 9y squared, leaving us with y plus 1. And then these 2 have a minus 25 in common, leaving us with y plus 1. Okay? So now you would have 9y squared minus 25 times y plus 1 equals 0. Now, 9y squared minus 25 is a difference of 2 squares. Those are 2 perfect squares. 9 is a perfect square, y is a perfect square, and 25 is a perfect square. So this will factor into 3y minus 5 and 3y plus 5. And then we still have our y plus 1 over here. Now, we have to set all of those equal to 0. 3 solutions. So we have 3y minus 5. We cannot just assume that the answer is positive 5 because of that 3 in front. So we have to move the 5 over. That gives us 3y equals 5. and then we would have to divide by 3. So one of our solutions is positive 5/3. Then we have to do the same thing for the 3y plus 5, set it equal to 0, which means this time I'm going to subtract 5. So I'll have 3y equals negative 5, and I divide by 3 to get that y is equal to negative 5/3. And then we can do the opposite of that one. So y plus 1 means that y is going to be negative 1. So we have 3 solutions there. Another grouping problem, we're going to group these two together. Looks like they have an x squared in common, leaving us with x minus 4. And these would just have a 1 in common, leaving us with x minus 4. So we've got x squared minus 1 times x minus 4. Again, we have a dot situation. This becomes x plus 1 times x minus 1 times x minus 4. Okay, dots means difference of two squares, so x squared and 1 are both perfect squares. So our answers are negative 1, positive 1, and positive 4. Okay? All right, give you a second to copy that all down. And then number 7 is we're going to find the zeros of the function and then sketch the graph. So on this one, your end behavior is going to be pretty important for how you're going to sketch that. Because what you're going to do is you're going to first factor to figure out what your solutions are. Because remember, all these numbers that we're finding today are all places where it crosses the x-axis. So in this particular case, they have an x in common. We have x squared plus 9x plus 20. Okay, when I factor this, I get x plus 4 and x plus 5. 5 times 4 is 20, and 5 plus 4 is 9. So I have 3 solutions. I have a solution at 0, I have a solution at negative 4, and I have a solution at negative 5. Now, the degree of this is 3, which means that all those places that I just found are all considered zeros of this function. So I can plot those. So this graph is going to go through the x-axis at all 3 of those places. My leading coefficient is a 1. So if it's a cubic, or an odd degree, right? So it's an odd degree and it's a positive leading coefficient. That means that the end behavior is going to start down and end up. My zeros are at 0, 0, at negative 4, 0, and at negative 5, 0. So if you're at home and you don't have your calculator with you to be able to check to see what's happening there, then you can pretty much kind of figure out that if this thing is going to start down here and end over here, then I'm going to start this graph, and I'm probably started out a little bit too far over here. So I'm going to start this graph, and it's going to come through this point, probably go up, come back down, and come through this point again. It's got to go through all 3 of those points. And so your sketch would be something like that. And again, I got that sketch because of my end behavior. My end behavior said I started down here and ended up here. And it had to go through those 3 points. You know what the graph looks like.